Hi everyone, so in this video we're going to learn how to implement an amplifier using an operational amplifier within LTSpice and later on Tinkercad, where the circuit is already assembled here, but we're going to do it from the very start. Very well, so let's start by clicking here on the new scheme, and to add an operational amplifier we're going to click here on F2, and this guy doesn't really have the operational amplifier we are going to use, but basically the setup is about the same. You can see them, all of them look very, very similar. So let's pick one of them. I think the one I was using was this dual single supply operational amplifier. I'm going to click on it and I'm going to add it on here. Now let's work first with the inverting amplifier. So to create an inverting amplifier, you should remember already. So we need a resistor up here and a resistor up here. And the way we calculate this in our case will be this guy divided by this one will be the amplification that I will provide to my signal. So I need a signal. Let's add a signal guy, signal symbol here, ground. I also need a ground for my operation amplifier because this is again an inverting amplifier. And now let's connect everything. So press F3 here for wire. And by the way, if you have the new version of LTSpice, the shortcuts are a bit more intuitive. So you press W for wire instead of F3. And there are some changes here as well, but you just need to hover the mouse and you will see the shortcut for it. I think for label in the new version you press N for net, but in this case here is F4. So I'm going to add a label here. That will be my VS for signal voltage, and here I also have my output voltage, which I'm going to call Vout. And I think I can connect everything here now. So F3 here to connect everything. Let's connect the resistor to the inverting side of the operational amplifier and the feedback resistor to the output. And then I will connect my ground to the non-inverting input and the signal here to this part. However, in real operation amplifiers, we need to provide them the energy they will use to amplify the signal. And that comes onto those two rails here, where one takes a positive voltage and one takes a negative voltage. And how do I generate a negative voltage? It is very simple. All you need are two voltage suppliers like this. So I will bring one here, another one I'm going to connect underneath. And you see here I have a plus and a minus, a plus and a minus. So if I connect this guy here to ground, as we always had, so I'm going to call this a V plus, and if I say that here I'm connecting V plus, we know very well already that, oops, I'm trying to make things, oh my goodness. All right, I give up. So we have here, let me try to move this R symbol here so it doesn't disturb us. We know very well that this will take, let's say, if I supply with 3 volts, we are going to have between the ground and this voltage here, we're going to have 3 volts, so we have 3 volts right here. What about for the negative? It works the same way, but the opposite. Instead of connecting the positive to here, I'm going to connect the positive to ground, and I'm going to call the negative V minus. And I'm going to link them with a wire. and then I'm going to connect V minus here with a label, and there we are. So if I say that this is 3 volts now, it will be minus this number that I have here. So in general, and we're going to do the same thing in Tinkercad, and that's exactly how we're going to do in the lab. You will need a voltage supply, two voltage suppliers, where one you connect the positive to the positive and the ground to ground, and the positive to ground and the negative to the circuit. That's how this works. Now let's give this signal here a sinusoidal wave. We're not going to use any DC offset, we don't need for this. Let's give it a very small amount, so let's say 25 millivolts. Very, very small signal. But I say we want to have that amplified and the output to be 1 volt, right? If I want 1 volt on the output, so let's bring the calculator here. If I want 1 divided by 0.25, I need a gain of 4. So this resistance here needs to be 4 times the resistance that I have there. Let's choose a value. So let's look at the standard standard resistor values, and here we have it. So let's try to find something that is about 4 times the amount. So let's say 6.8 divided by 1.5. That's about 4.5. Not exactly there. 4.7K divided by 1, also not there. 4.7 divided by 1.5, that's too small of a gain. Maybe 10K divided by 2.2, 4.5. Let's use this amount of gain to simplify and make the video shorter. All right, that's the issue with the reward. But this is going to work just nice. So let's get a value here. Yeah, let's use 10K and 2.2K. So I will use 10K here. Let's grab this guy, move it up here so it doesn't conflict. And if I type 2.2K or 2K2, that's exactly the same thing. That's how we usually put things into circuits. The same thing goes for mega and so on. So the circuit is ready, I believe. I have my voltage source. I have my power supply with V plus going here, V minus going here. So this has plus 3 volts, this has minus 3 volts. This resistance R2 divided by R1, that's about 4.5 gain. So if I have 25 millivolts, 25 times 4.5, we should have about 1.125 volts in our output. So let's simulate it. Oh, I forgot to give it a frequency, so we're not there yet. So let's give a very small frequency, let's say 5 Hertz. And to have 5 cycles into our output, let's simulate this for 1 second. So in 1 second, if this is 5 Hertz, it oscillates 5 times a second. We are going to have 5 oscillations within our output plot. So that's it, simulated. Now let's check our V out. Something wrong here, but all right. And my VS, all right, 25 milli. So, oh, sorry, 0.025. That is my mistake. That is my bad. I'm sorry. Times, yeah, that is correct. So we need more gain. So if I want 1 volt on the output and I divide by 0.025, that is 40. So I actually need here maybe 100K, right? So if I put 100K here and I simulate this again, now we see that our output voltage is about 1 volt and our input voltage is here. And because this is an inverting amplifier, we see that the output is the inverted signal of the input. And so when this is maximum, this is on the minimum. And let's go back to 100 to 10K to give it less gain, and those amplitudes are more equivalent. So you see here that when one is positive, the other one is negative. This is why it's called an inverting amplifier. Now let's look at it by the perspective of a non-inverting amplifier. How do we do the non-inverting amplifier? If anyone remembers, we are going to put our signal into our our non-inverting input. So let me close here and increase this again, zoom out a bit, and we will need to move some stuff around. So let's delete this and this resistor here. Let's just remove everything. Here, here, here. And I'm going to press F7 and select all of this and move below. There we go. Here should be all right. And I'm going to move this sign here to somewhere here. And now what I need is a connection between my output and my inverting input, so I still have that feedback. So let's connect it here, 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 and here. And for our non-inverting, we have to remember the formula for this one is a little bit different. It is R2 divided by R1 plus 1. So if we were to look at the slides here, which I forgot to open, our non-inverting, oh sorry, my mistake. Yeah, good thing I looked at this slide. We still need the feedback here, and that's our voltage divider, and our non-inverting goes directly to here. So oops, no, that's not what I want. F9, and I'm going to delete and include again my resistors. So R2, and let's do exactly how it is here on the schematic. R2 and R1 goes into the R1 is the one going to ground. So R1 is the one going to ground, and R2 is the one that connects to both sides. So here we are, and I'm going to connect this guy to ground. There we go. And we connect you here, and to make this, oops, I pressed F1 by mistake. I'm going to move this back here. So we have our non-inverting amplifier now. So if I give this guy here 10K, and this guy here, let's use just a normal value, so 2K. The gain here will be 10 divided by 2, that's 5, plus 1, that is 6. So 6 times 25 millivolts, so 6 times 25, that will be 150 millivolts. So everything is connected in here, and we should see our output by running and clicking our V out. So we see here now that we have our 100, close to 150. Probably this is considering some losses. But if I click into my VS, we see that they are in phase. So when this is in the maximum, this is also in the maximum. So this is how we'll implement the non-inverting amplifier. Apologies for the mistake at the beginning. I have my thoughts messed up. But let's look now at our friend here. So this is the circuit we're going to assemble, and this is the code we're going to do. Not this one entirely. There are some things that here I'm going to simplify. So let's start by deleting everything. Okay. Delete this guy, because then you will also see where they are. Okay, finally. So let's bring our Arduino in, so it is clean with default code. And let's bring our small breadboard here, that's all we need. And remember, we need 2 power supplies for our operational amplifier. I'm not going to use this 9 volts battery because the Arduino here supports this guy in particular. Remember, it's 5 volts. The one we have in the lab is 3.3. So I'm going to use a coin cell battery at 30 volts and another coin cell battery at 3 volts. And I'm going to connect them together. So the negative of one goes to the positive of the other. And these guys here, they go to ground. So I'm going to connect the ground here to this, to one of those ports. So it's alright that it's connected here. That doesn't really matter. But you see here that I'm connecting to this rail. So this rail will be ground. Let's give it the standard color for ground, which is black. This will be my negative. So you see here negative. So negative. I'm going to connect to this one here. And I'm going to give it a brown color. And the positive, I'm going to connect to this rail here. Let's make it look pretty, and red. So black is for ground, brown for minus 30 volts, and red for plus 30 volts. Let's now add our operational amplifier. The code for our operational amplifier is 741. This is the one that we have in the lab. So you see here we have our operational amplifier 741. And this is how they look in real life. If we look at LM741, you're going to see here is a general purpose operational amplifier. This is how they look, and this is how we're going to connect it to the breadboard. The good thing about Tinkercad, it tells you what the pins are. So if you don't want to look at the data sheet, which you should for the practice, for the simulation, you'll see here we have the offset, the in minus, in plus, the power minus that goes to the power supply. So this power minus here is this pin. So let's connect it already. So I'm going to connect this guy to our negative voltage. Here we have offset 2. We're not using offsets. I can explain what that is later if you just ask me. Power plus is this pin right here. So we're going to connect power plus to plus 3 volts to the red. And there we go. So our operation amplifier has power. It can amplify signals now. Our next step is to generate a signal. And for that, and in the lab, you have a function generator. Let's see if it's here on the shortcut. No, it is not. So function generator. I click and I'm going to drag it here. Now, unfortunately, this is going to look a bit messy, but that's all I can do. I'm going to connect the positive of my function generator into my Arduino so we can see our original signal. And our positive, for the signal positive, I'm going to give it the color yellow. And this guy here is the negative, so it just goes to ground. Let's connect it to ground. Here we are. Let's make it black. However, I also need to feed that signal into my Arduino. So let's do the inverting amplifier. In this case, just because it's simpler, I want my in plus to go to ground, remember? This is the non-inverting. Let's look at the inverting amplifier. So my V plus, my in plus goes to ground. So I'm going to connect it to ground here. That's it. And I'm also going to connect my in minus to the resistor and to the feedback resistor. Remember, we have to connect R2 from the output to V minus. So let's do this. I'm going to press here to add a resistor. I'm going to rotate this resistor. And I'm going to place it here, should be good. And oh no, this one is my feedback resistor, so let's add it in between our input and output. So in minus goes one wire here. That is my signal, so I'm going to call it yellow. And I'm also going to connect it. That's the part where it gets a bit messy, but bear with me. I'm going to go around here, then here, then here, here, here. So my signal is traveling through the wire in yellow. Then it goes into the, this is how I'm going to do. R2, I'm looking at this guy. Sorry, this is R1. R2 is here, so let's add R1. Rotate it. Yes, now we have it. So let me bring this guy in here. Yes, now everything is alright. And let's connect our R2 to the output. So output is here. I'm going to connect my output signal into here. And because this is my white output, I'm going to call it green. And from this green here, I'm going to connect to the analog 5 in the Arduino. So what is happening here? The signal generator is connected to ground. The ground is also connected to the batteries. So everyone has the same reference. And the Arduino ground, let's not forget this guy, is also going to be connected to the ground. So everyone is absolutely at the same reference. So if I put 3 volts here, this is 3 volts in relation to this ground, and the Arduino is going to read 3 volts in relation to its own ground. That's all I need to do. So this is connected to ground. This signal is connected to the Arduino, so I can read that voltage. And it is also connected to R1. From R1, it goes through the resistor. So let's look at the slide here. It goes through the resistor. Then it goes to the operation amplifier and R2. So it goes to the operation amplifier and R2. And R2 takes that signal that comes from the output and feeds back into the input. It takes the signal from the output in green and feeds it back into the input. And also I'm taking a sample of it and bringing to analog 5. My circuit should be complete. Let's now configure our signal generator. Let's put 5 Hz here as well. The amplitude, let's make it 0.5. And in here, amplitude, it's not the amplitude of the wave here, it's the peak to peak. So from here to here, it has 0.5 volts, meaning that from 0 to here, this guy has 0.25 volts, as we had here, but instead of 25 millivolts, I'm putting 250 millivolts. So the analog to digital converter can work well. Okay, we have 5 Hertz, 0.5 volts amplitude, and no DC offset. And I want a sine wave. There we go. Now let's code our Arduino. The code for the Arduino is very, very simple. Let's again go to text. Okay, I don't care. Let's delete everything. And let me call int original is equal to A0. So my original signal is in A0, and int amplified is into A5. Correct? Good. Now void setup. In my setup, I need to, because this is an analog to digital converter, I do not need to say that it is an input. It will assume that when I use the function analog read. So I just need to put here serial.begin, and let's put data rate here, the baud rate 9600, and that should be all. And now I can do void loop, and I'm going to say that my read is equal to analog read of, let's look at the original signal first, original, and my voltage will be the read voltage times the maximum voltage the Arduino can read, which is 5 volts, and divided by the resolution of the Arduino, 1023. Because it goes from 0 to 1023, that's 1024 bits. Nice. Now I just need to serial.println my voltage and close loop. So I'm doing the analog read of the signal that I want, and then I display the signal that I want here. I convert that signal into a real voltage so we can see it. I will open here the serial monitor, and the scope is active, and let's start the simulation. Hopefully everything works now. And I made a mistake here. Oh, of course, I forgot to say that it is an integer, or a float, even better. Float read, and there we go. Because we have decimal points, right? And also the voltage is a float. Okay, let's look at the output signal, and we see here a very small signal is being displayed on the output of this guy. So that's our 250 millivolts from here to here. I cannot, unfortunately, I cannot adjust this scale. Now I'm going to stop the simulation, and I'm going to start the original. I want to plot my amplified signal. If I run the code, it's still very small because I didn't give it any amplification. The resistors are exactly the same. So let's put, I have 250 millivolts. So now this is going to go, now this should reach 1 volt. So if I click here and give it 10K to this resistor, and for this resistor here, why is it not showing? I wanted to have 2.2K. And now if I play, and of course I show the output, you can see here that the signal is amplified, and you can see that with the Arduino. So this is it for this video. This is how you implement an inverting amplifier. I would give you the challenge of trying to do this with a non-inverting amplifier. Just remember, these are connected and these are connected like this. And because I have a break here, the spin is not short, right? So the energy is flowing from here to here to here. In the case of a non-inverting amplifier, I'll just leave this in, you can maintain those two resistors here because they still connect between the output and the input of the amplifier, the operation amplifier. However, instead of Vin connected here, we have Vin connected to the positive. So this resistor here goes to ground, and my yellow wire goes into in plus, and my ground doesn't go into in plus. So that's it. Remember, this is a tricky part to get the batteries working well, but just follow this schematic here and you should succeed both in here and in the lab. That's it for this video. I will see you in the next one. Bye bye.